Hey, what's up? It's your old pal, Mr. Cook, and we are getting ready for the Unit 6 quiz. Now, it's all on exponents and logarithms, so there's a couple of things that, like little rules that we need to kind of go over when we're going through this. The main thing that we have to remember, especially when we get down to about like here and number 9, basically through the rest of the problems through number 22, is that there's this way to convert from logs to exponents, and it's a formula that you're going to want to have memorized because it's going to be used basically throughout the entire unit. And it goes something like this, okay? So if I have an exponent, and this is just any exponent, that I want, I can rewrite this exponent in logarithmic form to solve for the power, x, okay? So I'm just taking these same variables that I'd have as an exponent and just rewriting them. Log base a of y equals x. These two expressions are the same exact expressions, just rewritten in such a way that I solve for x. So it's like the inverse functions. So we're going to use that a lot. So I just want to kind of keep referencing back to this over and over and over again, okay? Because you're going to be using it a lot, starting on number 9. Another thing that you're going to want to have out is a scientific calculator. So just get any scientific calculator that you have. I'll use this one. And also my TI-84, just kind of like, to show you that you can find all this stuff on a wide range of calculators. So if you just have a calculator, chances are if it's scientific, you'll be able to get all the answers that you need for the calculator parts. Okay, so let's work through a couple of these problems. This first one and the second one are just using the exponent properties, and we're trying to make the exponent expressions, combine them together in such a way that they only have positive exponents, and that's it, okay? So we're going to use a bunch of the different exponent rules that we have. I've in my class, I kind of go through like a set order by which I go through the problems. The first thing that I do, the first step is to just kind of, if I have parentheses like in number 1, I distribute any powers that I have into the parentheses. That's the very first thing that I do. The second thing that I do is get rid of negatives. So no negative exponents at that point. And then after that, I just finish simplifying. So I combine like terms. So combine, and I'm just going to rewrite it as combining like bases. But we know that it's the same idea, just combining like terms that we're used to seeing. Okay, so those 3 steps, and that's how I'm going to solve all this stuff here. All right, so the first thing is if I have parentheses with a power, I distribute the power in. So I have this 4 right here around the parentheses. So I'm going to distribute it into the 2 and also the y to the negative second. So I end up with 2 to the power of 4, and I also get y to the power of negative 2, so y to the negative second to the 4th power. So both of those parts have the positive 4 power on them. I also have a negative 1 as a power on the outside of these parentheses, so that's going to distribute into both of these parts as well. So I get x to the negative 4th raised to the power of negative 1, and then separately I get y to the 4th also raised to the negative 1st power. And then I have this y that's kind of just floating around at the very end there. So all these things are multiplying together, so I can combine them, divide them as I see fit. The next exponent rule that I'm going to use is the one that says that if I have an exponent raised to a power like this, then what I do is I just multiply the 2 powers together. So a to the m times n. And you guys probably remember that one from your algebra class when you were taught about that. So I do have an exponent raised to a power like this one, so I'm going to multiply these 2 numbers together, negative 2 and 4. So I get 2 to the 4th times, and then y to the power of negative 2 times 4 is negative 8. I'm going to do the same thing for the next 2 exponents as well. So I get x to the power of negative 4 times negative 1 is a positive 4. And then I get y to the 4th to the negative 1. So 4 times negative 1 is negative 4, so y to the negative 4th, and then times y at the very end there. And by the way, y is really just y to the 1st power, like that, okay? So next what we're going to do is take our powers and get rid of any negative exponents that we have. So if I have a negative 8 power and a negative 4 power here, both of those are going to go into the denominator because we start off with everything in the numerator. And if we have negatives, they can move down into the denominator and they become positive exponents. So this 2 to the 4th power stays in the numerator, 2 to the 4th. This y to the negative 8th moves to the denominator because it's negative, and it becomes y to the positive 8th. This x to the 4th has a positive exponent, so it can stay where it is, x to the 4th. And then this y to the negative 4th moves to the bottom because it has a negative exponent. It becomes y to the 4th. And then I have a y to the 1st all the way at the top here, so just keep it there. So next I'm just going to kind of combine stuff together as I can. And, evaluate any numbers that I have. So that's going to be the combine the bases part of it. So if I have 2 to the 4th power, if I can't do that in my head, I just do 2 to the power of 4, and I get 16. So 2 to the 4th is equal to 16, so 16. And then that's the only x value, so it stays the same, x to the 4th. Then I got a whole bunch of y values here. So let's try and evaluate them as best we can. So I have y to the 8th times y to the 4th, so that's y to the 12th. And then I have y to the 1st in the top. So if I have y to the 1st in the top and then y to the 12th in the bottom, I can divide out a y from both of those. And if I get rid of one of those y's, I'm left with 11 of them. So y to the 11th power in the denominator. And that's my answer that I can stick with. So that's number 1. So I'm going to kind of go through the steps a little bit quicker this time around. I don't have any parentheses, so I don't need to distribute any powers. So I get rid of the negative exponents. So this is the only one with a negative exponent. So if it's in the numerator, it moves to the denominator to become positive. So the only thing that I have left over on the top is that x to the 4th. Now I have a 3 in the bottom, an x in the bottom, y to the 3rd in the bottom. And now I'm also going to move this y to the negative 1st in the bottom. It becomes y to the positive 1st in the bottom. Next, I just combine all the stuff together. So 3 doesn't need to be raised to any power, so it's good to go. I have 4 x's in the top, 1 in the bottom. So if I, cancel out one of them, then I get x to the 3rd in the top. And then if I have y to the 3rd times y to the 1st, that turns into y to the 4th power because it's 3 y's times 1 more y, so it's y to the 1st. So there's our exponent, and we're all done. Okay, so that's the first 2 problems. And you can find way more of these to practice in 6.1 if you want. All right, moving on to the next group of problems. So solve each equation. So these ones we're going to have to find the same bases. So that's what we're going to be doing here. So find like bases. And once you have those like bases, you can set the powers equal. And then the last step is just to solve it, if you can. So let's go ahead and do that. So I have a base of 3 here, and I can turn 81 into a base of 3. Because 81 is the exact same thing as saying 3 to the 4th power. If I can get the exact same base of an exponent that's equal to that number, that's what I'm going to do. So 81 is 3 to the 4th. And once they have the same bases, so when I find like bases and they're equal, I can set the powers equal to each other. So if I set the powers equal, n minus 2 equals 4. And then solving for n, all you have to do is add 2 to both sides. So n is equal to positive 6. And then, you can go back and plug the number in, but that's your answer. Okay, this one looks a little bit different because we have this fraction, but when you see 1 over a number, it's actually really easy to just change that right away by using a negative exponent. So 1 over 6 is the same as saying 6 to the power of negative 1. And if you see any fraction, it's the same thing. Like even if I had 1 over 10, that's the same as 10 to the negative 1. If I had 1 over 103, that's the same as saying 103 to the negative 1. Like whenever you have 1 over a number, you can always do that trick, okay? And that's a common one that we like to do when we put together homework problems or quizzes and tests. It's a real quick way to get an exponent like that. Anyways, so you know how we try to make the same base over here? We're going to do the same thing here. And it just so happens that we can find a common base with 6 because 216 is really 6 to the power of 3. So I can just change that 216 to 6 to the power of 3, and then I keep that n as a power on the outside there. And then I have 6 to the negative 1st. And similar to how I had the exponents here, an exponent to a power, I combine the powers together by multiplying. I'm going to do the same thing here. 3 times n is 3n, so this becomes 6 to the power of 3n. Is equal to 6 to the power of negative 1. And once I have the like bases, I can just set these two equal to each other. So 3n is equal to negative 1. And then I just solve for n. So I divide both sides by 3 and I get my answer. N is equal to negative 1/3. All right, so that's the 4th problem. Now let's go on to number 5. Number 5 has bases of 16 and 64. Unfortunately, I can't raise 64 to an even power to get 16 and vice versa. However, both of these are powers of 4. So 16 is 4 squared, and 64 is 4 to the third power. So I'm going to use both of those as my bases, and then continue on with the exponent powers here. So that 16 turns into 4 squared, and I still have that 3m as a power. And then that 64 turns into 4 to the third, and it still has that same power of 2m plus 2. So remember that when you're doing these problems, these 4 problems, it's really, really helpful to get an idea of like how the powers work. And if you can kind of understand like one number and getting one power from it, like 16, for example, I know is 4 squared. That's an easy one to remember. You can try and see if that same base works for the other number. Like, if you didn't know that 64 was 4 to the third, you could always just try like, well, what's 4 to the first? That's 4. 4 to the second power, that's, 16. 4 to the power of 3, that's 64. So and then you can see that 64 is that number, so you can use that as your base value. So anyways, continuing on with these ones, so, multiplying the two powers together, I get 2 times 3m, that's going to be 6m, so 4 to the power of 6m equals, and then this 3 needs to multiply times this entire thing, so I distribute the 3 in there, so I get 4 to the power of 3 times 2, which is 6m, and then 3 times 2 is 6 again, so plus 6. Now that I have the same bases, I can set the equations equal. 6m is equal to 6m plus 6, and then I'm going to subtract 6m from both sides, and I get 0 is equal to 6. And when can 0 equal 6? The answer is that it can't. So that means that since these can't be equal, there's no solution for this one. So I can just simply put the no solution symbol, or I can write no solutions. So that's the answer for this one. There are no answers. So I'm going to do one more, and then we'll start up on another video. The next video will go by pretty quickly, maybe 5 minutes, and then getting into the solving ones even is pretty quick too. So, all right, anyways. Same thing is true for number 5 as it is for number 6. 9 can't turn into 243, and vice versa, 243 can't turn into 9. However, 9 is 3 to the second power, and 243 is a power of 3. It's actually 3 to the 5th power. So if I set those equal to each other, so 3 squared and then negative 3a minus 1, I just, again, multiply these two powers together, so I get 3 to the power of negative 3 times 2 is negative 6, so negative 6a. And then 2 times negative 1 is a negative 2. That's equal to 3 to the 5th. Now that they have the same base, I can set the powers equal to each other. So negative 6a minus 2 equals 5. And then solve. So if I add 2 to both sides, I get negative 6a is equal to 7. And then if I divide both sides by negative 6, I get a is equal to negative 7 over 6. And that would be my answer for that one. Okay, so that takes us through these problems. And these problems, if you want more examples of them, they can all be found in 6.2. And that'll conclude this video. I'm going to go on to another video to start working with the logarithms. All right, so on to the next one.